Hi, this is the retake ticket for learning target E. I want you to go ahead and first pause the video and take notes on the 3 different ways that we classify triangles by sides and the 4 different ways we classify triangles by angles. Please pause the video now. Alright, great. We're going to use one of those words for each classification. So if you look down below, we've got a few triangles pictured, and we are going to try to identify by its sides and by its angles. So we need to use one of those words from each of the categories. But first we need to dissect what we see on the screen and what we see on the paper, and how that can tell us the information that we're looking for. So the first triangle I'll start with is triangle A. If we start with by classifying by its sides, I see a 5 centimeter length here and a 5 centimeter length here, which means that the two triangles, or the two sides of the triangle, excuse me, are the same. Now, it's safe to assume just by looking at it that this third side here is not going to be congruent to the fives. We also know that this is 120 degrees, and if all the sides were congruent, it would have to be a 60-degree angle. So that third side is not congruent. It is isosceles though, so we will be able to take and define this one as isosceles. The next thing we want to do is we want to look at its angles. And it's usually one angle that will kind of tip us off to whether it's acute, obtuse, right, or all the same, equal angular. And in fact, again, it's true here. We've got this one angle in the center at the vertex of the isosceles triangle that is 120 degrees, which is going to make this triangle obtuse. Moving over to letter B, we have to approach this with the same thing. So I look at my sides first, and I notice that I have a length of 10 here, a length of 10 here, and a length of 10 here. All three sides are congruent. That makes this triangle equilateral. That makes this triangle equilateral. One thing to know about triangles is that however many congruent sides will be the same amount of congruent angles. And in fact, these angles are marked just the same. We've got a 60 in all 3 corners. 60-degree angle in all 3 corners means that this triangle is as well equal angular. Equilateral and equal angular will always go together. You cannot have one without the other. You cannot have one without the other. All right, if we move down to the other two on this page that ask us to identify by sides and by angles, the next thing that we need to do is look at letter C, take a look at all the sides, and you'll see that we don't have any of the same. We've got an 8, a 19, and a 23. None of those side lengths are the same, so this triangle is scalene. Scalene meaning no congruent sides. No congruent sides. Then you look at your angles. Okay, take them one at a time and try to identify what you can from there. We notice that we've got 110, we've got a 51, and we've got a 19. Even though 19 and 51 are acute, the one that is the most important to identify is this large one here. 110 is obtuse. All it takes is one obtuse angle, and the triangle is obtuse. Moving on to the last question in this set of questions, letter D, we again have 5, 7, 10 here, 3 different side lengths, and so I know that this is going to be a scalene triangle. But in order to answer the next question, we actually need to use the Pythagorean theorem to check. Now, this may look obtuse, this angle right here, but we want to be for sure. Okay, we want to be certain. So we are going to check using the Pythagorean theorem. And this is actually what we'll have to do on the next 2 questions. We are going to pretend for just a second that maybe it is. So I know 5 and 7 would be my legs, and I'm going to leave a space with a question mark because I don't know, is it equal, is it greater than, or is it less than our hypotenuse squared? 5 squared is 27, 5 squared is 25, 7 squared is 49, And so added together, this is 74. 10 squared is 100, so I will put 100 over on this side. And now we can answer the question. 100 is greater than 74, so I will open up towards the 100. What this means in the end, because this side represented my hypotenuse, is the hypotenuse got bigger, and anytime the hypotenuse gets bigger, the angle must also get bigger, and so this is an obtuse triangle. Obtuse triangle. We will continue to practice that down below. Continue on to the last two questions. It asks us to identify what type of triangles these are. Well, we need to use the Pythagorean theorem to check. So I will start out and I will just look at my longest side is 9. So if this is a right triangle, the 9 would be the hypotenuse. So I'll take my two legs, 3 squared, add it to 7 squared, and I will put a blank 9 squared. Because I don't know what is going to go here yet, I'm just going to leave a blank with a question mark in it. 3 squared is 9, 7 squared is 49, and so when we add those two things together, right on our calculator, we get 58. And I'll put that blank there, and 9 squared is 81. Obviously, 81 and 58 are not anywhere near equal. 81 is larger, so the obtuse angle is created because the hypotenuse is bigger. Okay, because the hypotenuse is bigger, this triangle is obtuse. Moving on to the next example, we want to do the same thing. First, identify what would be our hypotenuse if this is a right triangle. So I'll put an H next to the 18 because that is the longest side present. And again, I will use the Pythagorean theorem, just as we have practiced it in learning targets before. And I will see, again, put a blank, are these equal? Is it greater than? Or is it less than? And I'll type these simply into my calculator. 11 squared is 121. 15 squared is 225. When you add them together, you get 346. Blank, and 18 squared is 324. So again, we have a case here where they are not equal. If they were equal, they would be right triangles because the hypotenuse squared is the same as the legs squared and added together. But in this situation, this time, the hypotenuse was too small. Right? I always look at the hypotenuse. That tells me what is going to be the controller. And so if the hypotenuse is too small, like 324, then the angle got too small. And because the angle is smaller, we know that this angle must be acute. And so the triangle is acute. Flip the page over and continue practicing your own before retaking this test.